Welcome everybody, I am JJ. Let's tackle an example problem. So we're going to find Ix for our area shown. And here's our x-axis going through essentially the entire I-beam in this. We're given our info for what's our moment of inertia about the centroid of a rectangle and where's the centroid located at for this. But if we want to come in and try to tackle this, we have to use the parallel axis theorem for this because this equation isn't for an I-beam, it's just for a rectangle. So we can say our parallel axis theorem tells us the moment of inertia about any axis I want to take a look at. For this problem, that's our x-axis, is equal to the moment of inertia about the centroid of an object. For that, we'll have 1, 2, 3 pieces we use, plus our distance in between these two axes squared, d squared, times our area. So if I have 3 pieces, I need to do this 3 times. Just adding it together gets me my answer. So we'll go piece 1, 2, 3. 3 areas for me to work with in here. So let's just find all of those. Area 1, or I1, should be, so I'm saying my moment of inertia about the x-axis here is the moment of inertia about this rectangle centroid. That'd be base times height cubed over 12. My base of this is 8. My height is 2. 8 times 2 cubed over 12. Plus the distance from my x-axis to the centroid of shape 1. Well, that would go up 10 inches to get to the beginning of shape 1. So plus 10. From the beginning of shape 1, I have to go halfway in, the height over 2 to get to its centroid. Plus 2 over 2. Or my d distance here is 11. We square that and then multiply by the area. Times base times height, 8 times 2. Is going to get us that this is 1941 inches to the 4th. We can repeat that for shape 2. I2 should be, well, we have base times height cubed. Our moment of inertia about any axis is moment of inertia about the centroid. Base times height cubed over 12. Our base is 2. The height here is 10 plus 10, 20. 10 times 20 cubed over 12. Plus our distance from the x-axis to the centroid of shape 2. The centroid of shape 2 should be right on that x-axis. There's no difference in those points. It should be right in here. That distance then has to be 0. If the centroid of our individual shape is on the axis of interest, d is 0. Or really we could say plus 0 squared times the area. But if it's 0, this whole piece, this is going to drop away. There's really not a ton of value in me adding that in. That all goes to 0. We can leave that off moving forward. But we have 2 times 20 cubed over 12. That will get us a moment of inertia here is 1333 inches to the 4th. And then we just repeat that for I3. I3 is our moment of inertia about our x-axis is our moment of inertia about the centroid of shape 3, base times height cubed, 8 times 2 cubed over 12. For shape 1, I went up 11 inches. Here I'm going down 11 inches. That direction makes 0 difference in my work, though, because I end up squaring it. Really, my d distance here is the exact same for shapes 1 and 3 because we're symmetrical. So plus 10 plus 1 over 2, or plus 2 over 2, squared times the area, 8 times 2. It's still 1941, equals 1941 inches to the 4th. Adding those 3 things together, I'll get my total moment of inertia. I is I1, 1941, plus I2, 1333, plus I3, 1941. Or my total moment of inertia here is 5,215, 5215 inches to the 4th, which is my final answer. Hopefully this is a useful video for us. If it was, hit those like and subscribe buttons. Let's watch more videos and get you an A with JJ.